Hi mathematicians, we're in section 2.6, continuity of functions with roots, and basically if n is even, then the nth root of f of x is continuous everywhere f of x is positive. If n is odd, is continuous everywhere. Right? Basically, we know this, right? This can have a negative answer, right? So f of x, if n is odd, right, this would be our n here. If n is odd, we don't have to worry about f of x being positive. But if n is even, right, we have the square root. We're not dealing with i's here, right? So if n is even, then this f of x has to be positive. So it's basically saying if you have something to the nth power, 1 over the nth power, okay, you're just going to go ahead, it's continuous everywhere unless you have this problem where you're even and inside is negative. Okay, so let's go ahead and talk. It's the same problem we always have, right? You don't want the inside to be negative if you have an even root. So let's just do a couple examples. Suppose we have g of x equaling the square root of 9 minus x squared, right? So here n is 2, right? N is 2, right, in here. And so it's even, since even, 9 minus x squared, we can't have that equal to 0, so we need to find out when that happens. So solving this here, we end up with x squared equals 9. So this happens when x equals plus or minus 9, we get a 0 in there. So that's fine for a 0, right? But what we don't want is a negative number. So when we get outside of the realm of this 3 on the number line, right? So we have 1, 2, negative 3, 1, 2, 3, positive 3, right? And everything in here is okay, right? 9 minus 0 is okay. 9 minus 1 squared is okay. 9 minus 2 squared is okay. All of these values in here are going to be okay. We're not going to have negatives here, okay? The corners or the edges are okay too because we get the square root of 0. But what's not okay is once we get outside of here and we're subtracting 9 minus 4 squared, 9 minus 5 squared. That's where we're not okay. So asking where are we continuous here? We're continuous on the interval negative 3 to 3. Okay, another problem, let's see, where is this one continuous? F of x equals x squared minus 2x plus 4 to the 2/3. Okay, what does to the 2/3 mean? Well, I can rewrite this if I want to. Like this. Okay, and so we see that we have an odd here. So there's going to be no restrictions. Because f of x is continuous. Well, that's what I want to write. Because x squared minus 2x plus 4 squared is continuous everywhere. And n is odd. Okay, so both of those things together tell me that this is continuous everywhere. The interval is negative infinity to infinity. This is continuous everywhere. If this is odd, we have no restrictions. Okay, so that's continuity with roots. Let's continue on and talk about some continuity of trig functions. Okay, still 2.6. And so sine of x, cosine of x, tangent of x, cotangent of x, secant x, and cosecant x are continuous at all points. In their domain. Okay. Let's go ahead and look at the limit of a trig function here. Limit and so if I look at this, the first thing I want to do is I want to go ahead and factor the top. So this is going to be the limit as x goes to 0 of cosine x plus 1, cosine x minus 1. Cross those out, you get the limit. X goes to 0, cosine of 0 plus 1. And of course we get the answer 2 here. Okay, we really don't have to worry too much about continuity of most trig functions, like I said, because, you know, if we look at our friendly sine, look at our friendly cosine, right? There's no problems there. Okay, so that's a quick continuity of trig functions problem.